Hello, my name is Richard Mills. I am a DevOps solution architect with Coveros, and today I'm here to talk to you about a DevOps approach to ensure quality in microservices. Before we get started, just a couple minutes to talk about myself and kind of introduce. I started out my career as a mad software developer, if you will, building a lot of software, and that kind of evolved into me being a mad software engineer, in which I was very, very focused on more than building software, but how it is we build software and how we effectively gather teams together, use tools and automation, things like that to get things done. That has eventually evolved into me being a DevOps solution architect, where I get to use tools and automation to help my customers build software. One of the things throughout my life is I've very much been a pragmatist in that really I'm just looking for ways to get things done and find ways that we can build high quality software better, faster, cheaper, et cetera. Through my career, it kind of started out as continuous integration, then it became continuous delivery, then Agile came along, now we call it DevOps. I'm really just looking for what's next and how we're going to continue improving the way we build software. Oh, by the way, thanks for the industry for inventing terms like CI and CD and DevOps to describe the things that I've always, quite frankly, loved to do. I work for a company called Coveros. Coveros is a boutique software engineering and consulting firm. We focus very heavily on Agile and DevOps. And Coveros really has given me the opportunity to work with a variety of customers over the years, often with very challenging problems and how they're building software and how they're making money and getting software out the door. And all this information that I'm going to talk about today really is based on my experiences with one or more, a couple customers really over the last few years as we've gone through this journey of whatever we're going to call microservices. So let's get started with that. So why am I really here? I'm going to talk today a little bit about some of the problems that I've seen with microservices, and especially what I would call non-ideal microservices. What is it that we do wrong that don't quite get them right? And I'm going to talk about what I mean by that, right? I'm going to go over a little bit of what I will call a reference DevOps pipeline and the design of it and what it really means that when we talk about DevOps and how we use that to deliver and build our software systems. That'll give you kind of a context example of, a little bit of a microservices system that I've seen and how I will refer to it as non-ideal. But most specifically, what I want to do today is talk a little bit about how you can use DevOps and the approaches and the philosophies and the tools and the techniques thereof to enable testing and improve overall quality of these systems that you're building, and a little bit about how that relates specifically to microservices. So let's talk about that. Before we really go too far into what we mean by testing and quality, I want to talk a little bit about my experiences with microservices. And one of the things I've seen in microservices is it really utopia? Is that the best way ever to build software, or has it turned out to be a nightmare? And depending on how things go, it can be a little of both in some situations. So for a lot of my customers and a lot of people I've worked with, everybody goes out and they read the internet over their lunch period for a while, and they're like, you know what? Microservices are all the rage. It's the best thing ever. Let's take all of our busted monolithic systems and we're going to split them up into smaller systems, and they'll be easier to manage and easier to deal with. Yeah, that's what they said, but unfortunately, it doesn't always quite go that way. What I've found is that successful microservices really require a combination of technical architecture, automation, testing, and a development methodology that all relate very closely to what we now see as Agile and DevOps. And then often without the right mix of these, things don't quite go as well as we'd planned in many cases. In my mind, microservices is a little bit like herding cats. And if anybody ever saw the EDS commercial with the Cowboys herding cats that I think they played during the Super Bowl, it's hysterical. It totally talks about my life. But what I've seen is that what I will call microservices in a non-ideal real world is that, sure, you end up with a bunch of federated services that are all working together, and it's a bunch of different systems. And the desire was to break them up and get rid of the coupling in the huge system. But you end up with these federated systems that have these hidden dependencies between them that are no longer as obvious as they once were, perhaps when you had a giant monolith. The other thing we find is that these microservices are often being managed by a bunch of different teams. So each team owns their own microservice, right? And a lot of times these teams are off running at their own pace, and they don't necessarily talk to each other or communicate with each other as well as they should. And that can lead to problems. So what you end up with is you have many things changing at different rates, and some will change fast and some will change never, almost, right? With these quote unquote decoupled interfaces that, quite frankly, become very hard to verify independently. So people don't publish their interfaces properly. They hide behind their interface. They're like, oh, we published an API, except for they don't document it that well, so nobody understands that. And they have all this freedom to kind of move at the pace they want. But the teams aren't coordinated as well because they're managed independently. They're, quote, agile, which means they get to do whatever the heck they want, right? Yeah, not so much, right? There's a reason there's process and formality behind agile, and it's because we need to get people to work together. So what we find is what we were targeting was to have the desire to be able to deploy small changes on small systems into a production environment very quickly. The problem is, that now we've run into a situation where, well, we got all these services changing at all these different times, and we can't figure out which ones work together, even in test environments, much less as in production. So you get this kind of paralysis or this churn of everybody's trying to test different things. And they're like, does this work with that? Do we know that? Oh, that service changed and it broke a bunch of stuff. How do we deal with this, right? And what we find is that you need to find ways to bring teams closer together so that they have ways to communicate, and not just talking, but also just the way to share their interfaces, share the implementation of their tools, so that they continuously integrate their services together so that they work in concert with each other, right? We need to deploy these integrated services into various environments, and again, do this at different rates and at different times. And then frequently test the unfortunately still monolithic system, both in pieces and as a whole. So what does that mean? Well, to me, this looks suspiciously like a DevOps problem. It's our delivery process. It's how do we go through these things to bring teams together, to integrate things, right? So these are all a lot of the spirit of exactly what we're trying to do with DevOps. And it's one of the reasons why DevOps and microservices really go hand in hand. We definitely find that automation is critical to everything that we're doing. I was talking at a conference, right? I think one time a few years ago, a happy hour somewhere, having a great talk with a guy, and one of his quotes, and it's his favorite quote, I wish I could remember who this guy was, but he said to me, if you are building microservices and you don't have a highly automated CI/CD pipeline in place, you've already lost. And I completely agree with the guy. Because what I found is that your DevOps pipeline, and especially, by the way, with integrated testing, is critical to your success in building and deploying these services. So let's talk for a minute about really what we're talking about. So what I want to do is give you a little example of some of what I've seen with kind of a microservice-based system, because that'll allow us to kind of frame up the conversation. I was working on a project a couple of years ago, and we had a dozen-ish independent services. By the time we're done, I think it was a dozen, maybe 2 dozen different independent services that were being managed by half a dozen different teams. So any given team might have 1 or 2 services, right? And this was all kind of this one big federated project or product, quite frankly. It was a seamless, like, customer registration system type thing. And it had a workflow system built into it and all different people doing different things. And it was all built on fairly modern technology. It was React, JavaScript front end. It had Java Spring Boot REST services behind it using a Postgres database, some various backend stuff. But, fairly classic architecture kind of thing where each of these components had a nicely isolated user interface. It had some kind of API REST service behind it that did some of the work, and it would have its own data store to do things. And then overall, the whole set of services were integrated together in a consistent UI on the front through this, what they call the page service, right? But all these different services were all changing at different times, different people implementing it. There's some external services we we connect to. And this, quite frankly, is a fairly common architecture I've seen for people who are trying to move from monolithic to a microservice architecture, even starting out as microservices, where you have, a dozen or so services to do different things. Well, we would take these services and then we would deploy them in multiple places. And in our particular case, we were running Docker containers that were being deployed into an OpenShift Kubernetes distribution set of clusters, right? So this was containers and microservices and Kubernetes, and it was very buzzword compliant, right? We had all the buzzwords we needed to do the right stuff. It was all going into Amazon Web Services. And what we see is kind of across the bottom, we had a dev cluster and a test cluster and a production cluster. And that was really just a group of, for lack of a better term, it was a group of servers and nodes that were grouped together and allowed us to deploy the different bodies of software across these clusters. And then we had another cluster of services, if you will, that's that kind of DevOps cluster at the top, where we had things like Jenkins servers and Nexus repositories that were all orchestrating this whole thing, right? So this is where we start to talk about DevOps and getting to what do we really mean by that? What do we need to do with DevOps and whatever we're talking about related to software? Because it really comes down to, on the previous slide here, I have a bunch of software and I have a bunch of people changing things. And at some point, I got to figure out how to get it into all these different places, verify that it works, and then, potentially promote it to other places. And I'll talk about that in a few minutes. So when I say DevOps, it's interesting to kind of step back and think about, well, what do we really mean? Because a lot of people mean different things with DevOps. If you search for DevOps anywhere, you're going to find a whole bunch of different buzzwords, right? Things like DevOps in the middle and agile, continuous delivery, continuous integration, continuous everything, testing, right? All these words will show up all over the place. But one of the things you may notice is that not many of these words are purely the responsibilities of a single person or a single team. A lot of times, this is the responsibility of a group of people that have to work together to be able to do things. And what I really start to mean by DevOps is DevOps has become the natural evolution of Agile, right? It's how do we get working software into the hands of the people who need it rapidly and reliably, right? And that's really what Agile has been professing the whole time. The different principles of Agile, and that, okay, we're building working software. We want to get it to our users. We want to do things. We want to do it in small chunks, right? Well, DevOps has really become, in my mind, an enabler of that, which is we've needed DevOps. We just may not have known it until we tried to do things with real Agile software development. And when I talk about delivering software rapidly, I mentioned you got to deliver it into the hands of the people who need it. Well, who really are those people? Well, depending on where you are in your life cycle, if you're fairly early on in your product development, which we were for this project, it was a greenfield project. Sometimes those users are really just developers, right? They're product owners, or the people that want to see the software evolving and need to be able to reflect on it and test it and assess it, right? Ultimately, those people are going to become your end users, right? As you start moving towards a production kind of operable environment, they become your end users, right? People say, well, when do we need to get this done? And my response to them was always now, right? One of the purposes of DevOps, one of the purposes of Agile, quite frankly, is to be able to do this as rapidly as possible. You should be able to take a change in a piece of code and deliver it into a running environment in minutes, right? Maybe a handful of minutes, maybe a dozen minutes. But the point is, you should be able to do this quickly to get it deployed somewhere so that people can start using it. They can start testing it. They can start assessing it, right? And the question then becomes, how do we do that? And the answer is, well, team collaboration. I'm going to harp on that a lot, right? You got to have teams that work together and not just throw it over a fence at the next team and hope for the best. So you need team collaboration. But in order to do it effectively, and especially with microservices, we need processes, we need automation, and we need tools. And really, you can't talk about DevOps without talking about some of that stuff. So we're going to definitely talk about some of that stuff today. But I really come back to that DevOps is really that extension of Agile that has allowed us to kind of realize what we wanted to do with Agile since the beginning, right? It focuses on value delivery, right? It's about how do we take software and get it where it needs to be, right? And to me, this is common sense. This is the way to do it. And I've never really thought of a different way, which is it's through working together, it's through deployment automation, it's through testing automation. It's all these things I'm going to talk about today. Because what we're really trying to do is we're trying to enable developers to be creative and do great work, right? We want them to focus on the creative aspect of building software and not on the mundane tedious toil of how do I compile my software? How do I upload it to a server, right? Those are all the kinds of things we can do with automation. And quite frankly, computers are just really good at doing that kind of stuff. So DevOps has become especially important in that world of microservices, because if you think about it, if you only had one software system and you had to go through some of that toil of maybe building it, maybe uploading it, maybe deploying it, maybe configuring it, not that bad if you have only one system, right? Maybe it takes a long time because it's a big thing, but it's not too bad. But in microservices, that rate of change and the number of teams and the services involved makes it virtually impossible to keep up with without automation. You can't do it manually, right? And the other thing that we find is you really need to focus on quality, because if you don't, you're going to build this super fast automated pipeline that's going to push your code out really quickly. But if you don't have testing and quality, and you don't build that into the system, you're just going to end up pushing really bad software really fast, right? So that's not what we want, which is why we need to focus on quality. So at Coveros, and this is what I've kind of learned over my years, one of the things I've worked with my customers many, many times is that a DevOps solution for whoever you may be involves really 4 key things. The first one is team structure, right? And you need the skill sets across the delivery chain of everything from writing code to testing code to delivering code. You need those skill sets, and you need those teams to work together to be able to do this effectively. You're going to need infrastructure and tools, right, to support all of this automation and team collaboration you're trying to do. You're going to need a delivery pipeline, right, which is, quite frankly, the set of software that you're going to build that will build, package, deploy, and test your repositories of code that you're going to build, right? And when you have microservices, you tend to have many repositories of code, right? And then finally, you're going to need test automation. And you're going to need lots and lots of it that is capable of evaluating the changes and the software that you're actually building. All of this gets wrapped up into some supporting agile development methodology. And I'm going to call this whole thing DevOps, right? And this is what we want. So overall, what we want is the ability to deliver independent changes into a working environment rapidly and reliably while maintaining a high quality system, right? And that's exactly what I said a few slides ago. And this is kind of how we do it. In order to do that, how do we do this rapidly and reliably? Well, you can't talk about DevOps without starting to talk about things like delivery pipelines, right? So in DevOps, we always have this thing that we call a pipeline, right? And what it does is it defines what your company's delivery process is, or at least it mimics it and it automates it, right? So the software delivery process of whatever steps your company goes through to build software gets automated through this CI/CD pipeline, continuous integration, continuous delivery pipeline, to deliver application microservices into the various test and eventually production environments where it's going to go. And when I talk about CI/CD pipelines, I typically divide them up into 3 kind of major phases, if you will. The first step on the far left is what we will call continuous integration. And the responsibility of continuous integration is to take whatever code is being built, to compile it, to run some unit tests and do some assessment, but ultimately to package and publish it so that it is ready to move on into the world and be installed and configured. And in the case of microservices, used in concert with other services, right? Because then you move into what we will call a continuous delivery phase, right? And here, this is where we're like, okay, now I need to install it somewhere. So I need to provision some kind of resources where I can put my software. I'm going to have to install the software. I got to configure it. So really what I'm trying to do is enable my ability to test it, right? I'm going to test it either by itself or potentially with other services, such that if it passes, I can eventually promote it and I can move it through and I can start cycling through this where I'll go to a dev environment, maybe a test environment, and finally, ultimately somewhere, a production environment where it's going to live and be used by its users. Certainly once it gets there, we have this other phase that we call continuous monitoring. And this is really with, okay, our software's there. How do we monitor it? How do we examine it? How do we make sure it keeps doing what it's supposed to do, right? For the sake of today's talk, I'm not really going to talk about continuous monitoring very much, but it is a very important phase of this whole continuous delivery and evolution cycle. Right. Now, one of the things we see kind of across the bottom is that every one of these phases, we have all kinds of opportunities to test the software. We have unit testing, we have code scanning, we have package dependency checking, right? So there's all these things that we can do just during this kind of CI phase on the far left to start assessing our software and try to find problems as early as possible. Right? Once we move into a deployment phase where we're deploying it and testing it and trying it in different test environments, we can do things like security vulnerability scanning. We can do deployment verification. We can make sure the software came up properly, smoke test it. We do all kinds of actual testing on it, whether that be manual, functional, non-functional, etc. Right? And I'm going to talk a little bit more about these today. But the dominating force here is the whole reason we're doing all of this is so that we can test it, right? Because what's going to start popping out of the bottom down here is we're going to see, we're going to get results about code coverage. We're going to find bugs and vulnerabilities. We're going to find, different kinds of test results that are going to cause us to react to our software, where we're either going to build confidence that the software is good, or we're going to find things like defects that need to be changed and fixed and cycle back through this process again. And hence, more automation, more execution. For every piece of that pipeline that I just showed you, one of the things to realize with microservices is you don't just have one pipeline. You effectively end up with a pipeline per microservice. So every microservice tends to have its own code base, and it's got a pipeline associated with it that picks up and starts executing to build it, to compile it, to test it, to publish it, to deploy it, right? So all of these microservices are going to be built independently. They're all going to execute in parallel effectively at different rates. What we've learned over time is this can be very resource intensive, because if you've got 20 microservices and they're all changing at the same time, they're all being compiled, you need a pretty big build server that can handle that. And you need to build in that kind of scale. So lesson number one, building things in microservices, you need again, lots of automation, but you also need lots of scale and a lot of resources. And ideally, you don't want to do things like launch 27 different servers that sit there most of the time and do nothing and then suddenly wake up, right? This is where we start looking at things like, how can we auto scale these servers? How can we build our infrastructure so that they're elastic and they make use of the cloud and they do all these fun things that make us so that we pay for the right amount of resources, but not all of it. So we're going to fire up all these resources and they're going to be running in parallel doing things. Well, eventually I'm going to build these services and I'm going to have to deploy my application somewhere. Right? So I need, quote, an environment, right? That's typically what we look at for test environments, right? Where if I've got 4 different services or 5, I've got, a web service in the front and A, B, C, and D services in the back, I need to be able to deploy those at some point somewhere so I can execute them and run the typical kinds of tests that they always do. Well, one of the questions you might ask is, do I put these in a mixed environment where they're all being, as soon as they compile, they all go into the same environment, the same place? Or do I give them potentially their own environments where I test them all independently of each other? And the answer is, well, it kind of depends, right? And I'm going to talk more about some of the patterns of when that works and it doesn't. But when you have static environments, I'll say that one kind of, it's in the middle there, the left of the 2 environment boxes. Sometimes you have issues of if multiple services are being deployed in there at the same time and you're in the middle of a test cycle or something else is going on, you may find yourself causing problems that you don't expect or don't understand how to handle. And this is where, quite frankly, dynamic environments become very beneficial. And when I say dynamic, I mean dynamic, on-demand, or ephemeral environments where I can launch a brand new test environment with all my microservices in it at any given moment, because that really enables me to have more flexibility with how I stand up my environments, what I'm testing, and when. Because quite frankly, I'm going to install all these things, and at some point I need to analyze them, and I need to know enough about the state, if you will, of my environment to know how to put the context of what I'm going to find. Which leads us to, how do we ensure quality? How do we use these environments? How do we use this pipeline to actually figure out what we're trying to do? Often we refer to this as testing. one of my big statements, right, and this leads directly from what I was saying earlier, is that your efforts in DevOps and microservices, frankly, will fail without proper automated testing and assessment that is fully integrated into your pipeline. All these things that I'm saying, I believe 100%. Without automated testing, no matter how much you dislike testing, it is absolutely critical you find ways to tie it into your pipeline. Because our goals for testing in this DevOps world, especially with microservices, is one, we want to keep our software in continuous working state. We can't go through phases where the software gets broken and stays broken for any period of time. Because when this happens, what tends to happen is more things break and pile up behind it. And suddenly you get the equivalent of a giant traffic jam because you don't realize what's broken or where anymore. So it's important to keep the software in a working state rapidly, like at all times. And if it does break, fix it as quickly as possible. Second point is really what we're trying to do is establish confidence in change, right? Because if I know that I can push a change into an environment or push a change towards production, and I trust my testing, that gives me the confidence that I can continue moving forward rapidly with my changes, right? And again, this becomes important with microservices where you're trying to establish not only confidence of your own service sometimes, but confidence that you haven't broke other services in some way that you did not expect, right? Third point becomes we want to force our teams to focus and build quality into what they're doing, right? They need to recognize that quality is a huge important to this. And if people start falling to the side on quality, suddenly you end up with this big mess and this traffic jam that I talked about in the first place, right? So we want teams to agree that it's important and focus on it and live up to it, right? So it's establishing those high technical standards and using testing to verify it. And then finally, it helps us a little bit to avoid building too much technical debt, or at least too early in the project. You know, one of the things when we were working on this project with our customer a few years ago was that it was a brand new project, right? People were going fast and furious. They're building lots of code and they didn't have time to test it. We got to get stuff to work. We got to get a prototype. And I was like, okay, that's fine. We're willing to accept some level of technical debt. But if we start building frameworks of testing, of analysis as we go, that allows us to start at least understanding what this technical debt is and places we're making decisions where we're going fast for a reason, at least we can come back later and catch up on some of that technical debt, which is always very, very hard, right? One of the important things I will say here is anytime I'm using the word quality here, I actually mean quality, security, performance, and any of the other, availability, maintainability, any of the other abilities that you can think of in your software. It's basically, how do we define good software? And that's really what I mean by quality, which leads us to what we call quality gates. And this is fairly common in DevOps, and it's fairly common in any promotion process where we find the quality gate to be a critical aspect of CI/CD, and especially in DevOps, which is we usually fill it with some kind of automated testing or assessment. How do we assess quality as early in the process as possible and as many ways as possible to understand that we're not letting bugs, we're not letting defects, we're not letting quality problems escape, right? And one of the important things about quality gates is they are designed to stop progression if they fail. By a quality gate, we're not talking about, oh, we know that our quality is 36. Or even that we know our code coverage value is 72. Like, what does that actually mean? It's a number, it's a something. A gate is a binary. It either passes or it fails. It's not, oh, well, we had 13 tests that failed. Maybe that's okay. Now, if anything, you have a number like that, you have a threshold, right? And I don't think 13 tests failing is a good thing, but like coverage, a lot of times people will say our coverage threshold is 70%. And if you have a quality gate at that, it means when it falls below 70%, it fails. The pipeline stops. Your software doesn't go any farther. And that's an important aspect of quality, of quality gates themselves. So what do quality gates look like maybe in a DevOps or a pipeline process? Well, I can kind of lump them into a series of categories that these typically appear as when I'm working on projects with my customers, right? So the first is static analysis, right? And this is where we can do quality and security source code scans. We can use tools like SonarQube. I'll talk about that in a minute. But the whole idea of this is before the software runs anywhere, I can scan it and look for certain types of known problems, right? I can do things like composition analysis, where I'm looking at security dependencies of, are we pulling in, insecure or vulnerable components off the internet, right? I can do all of this stuff before I ever actually try to run the code anywhere. Right. Then we have functional testing, and there's lots and lots and lots of functional testing where you're basically trying to prove that the software meets its specification or does what it's supposed to do. Right. And this starts early on. It can be unit testing. It can be API level testing of your REST services. It can be UI level testing. Right. Eventually we get, some clicky user interface on the front, and we can test that as well. Right. There are also what I will call deployment or smoke tests, which is we're building all this automation. A lot of times we have to prove that the automation itself works. And sometimes the easiest way to do that is to launch something and make sure it actually came up the way you expect it to. Right. So these are all kinds of functional tests that we can do to gain confidence that our software is doing what it's supposed to do. There is, of course, non-functional testing, right? And this is where, you might do security testing, some kind of penetration testing, other scans for vulnerability. We can examine the software. Performance testing, right? Maybe we use JMeter. Maybe we build out some either very simple baseline tests into our pipeline, or maybe we have a full-blown production environment somewhere, or performance environment where we're testing more comprehensively to figure out what the load, stress, performance and limit testing could be on our software. All of these fit into our DevOps process, right? And then ultimately, I said I'm not going to talk about a lot, but real-time monitoring, which is once the software is out there, just because it's good now doesn't mean it will stay good, right? So again, this isn't a quality gate as much as it is a monitoring system where eventually it's going to throw some threshold. There's going to be some alert, and it's going to require action for us to do what we want to do. And that's, again, things along the lines of observability. So what do we do with this? Where do we start? I tell people, always start with static analysis, right? If you are not scanning your code, go out on the internet, download SonarQube right now. You can get it installed and running in probably an hour and a half, and start scanning your code with it, right? The whole idea of static analysis is that code scanning, a tool like SonarQube gives you quality dashboards. It gives you a way to post what's going on. It includes things like quality, security, maintainability, for a lot of different software languages. And it really just gives you this kind of continuous view as early as possible in your editing and change cycle of what your code health is. It can record unit tests and coverage and show you where you stand. And it allows you to set these thresholds and to break your software if you are below a certain grade or things like that. So SonarQube is a great place to start. If you're not doing any static analysis, go find it and do it. Because as we drive into these other forms of testing, one of the key kind of tenets, if you will, or my position on these kind of imperfect microservices that aren't quite, as isolated as we want to, is that there are in fact dependencies between them. We may or may not know what they are. So my premise is that your microservice and your API interfaces that go with them are going to be probably poorly documented, probably going to change in unpredictable ways over time, and quite frankly, be poorly tested in most situations, at least to the sense of how I think they should be tested. The corollary here is that your teams will neither admit nor communicate this very effectively, nor maybe even know, right? There's a lot of times people, I'll have microservice teams and they'll change pieces of code and they don't even realize that they broke it, right? They thought it was fine. Oh, we didn't actually change the external interface. We just changed the way it was doing something. And then you realize downstream that effect, the way you were computing something, the way you were returning some piece of data, suddenly something else broke somewhere, right? So in my mind, the solution is to test the snot out of all of these interfaces, right? We want to exercise the interfaces. We want to focus on things like integration and understand what's changing and why and where. Because if it's not real documented and maybe I didn't expect it to change, at least if I test it, maybe I have a better idea that it did change and what the impact of that is. So when and how do we do that? Well, I find that there are a lot of test opportunities throughout your CI/CD pipeline. And at a very high level, we can take a look at this diagram. But as you progress kind of left to right through this pipeline, there are many, many opportunities where you could inject some tests and do some things, right? And along the way, what we're always trying to do is find the next most valuable test as you progress. You're going to do different kinds of testing on the left than you're going to do on the right. What we don't want is just to keep rerunning the same tests over and over again, right? So if I start on the left and I've got, I don't know, 3 or 4 services over there, I might start with a little tiny testing where it's unit testing and I test in isolation. Eventually, I may actually want to take that and I may want to deploy my software into some kind of like ephemeral on-demand environment where I can do, some actual deployed testing where it's running, and it's configured, and it's doing some stuff. And then I might take that and I might take multiple services and deploy them together into a development environment somewhere where, again, another opportunity to test. I may promote that to UAT or QA or a pre-prod environment, find more tests, and then eventually I go to prod and I do even more tests before I get there. One of the key points that I'm trying to say here is that the tests that you do in a ephemeral environment, if you've already proven the functionality of your software, don't just run the exact same tests in another environment. What you're trying to do in the next environment is probably prove what's different between those two environments. How do you exercise the right kind of test to maybe perhaps focus on integration this time instead of just basic functionality? In absence of, you don't have those tests yet, sure, go ahead and run what you got. It's better to rerun them and find out things, but it's also inefficient, which is if I already tested and proved that the functionality works, why am I doing that again? The answer is usually, oh, well, it's different in that environment. I was like, okay, if it's different in that environment, that's what you want to test. Because what we find is that we eventually get to a point where we find that dynamic on-demand environments can serve some of these pieces, right? So if you start looking around, like current project I'm on, I think we have like 12 different static test environments. And a lot of times I look at them, I'm like, what purpose do these serve? What are we testing there? What are we doing with it, right? Because what we found is that in a dynamic environment, I can launch it. I can control exactly what goes into it. I can reproduce it, and I can test the functional stuff I want to. It allows me to test out things where, oh, well, maybe if I can deploy a dynamic environment, then what I can really do is, I can start examining deployment patterns like A/B deployments where I deploy, a little bit of this feature, this upgraded feature there, I run them together and do things. Or I can do a blue-green deployment where I launch a brand new environment, stand it up next to the old one, and then just throw the old one away and turn on the new one. And I get very kind of rapid deployments of what's going on. Or even canary deployments where I take some new feature and I throw it out there. I was like, well, let's see how this thing runs. Right. So there's different things that we can do as we start constructing and building these test environments. I mean, in our particular case, in this diagram here, sure, I already said I have a cluster with a bunch of Jenkins and different tools stuff in it. We have our dev test cluster where we did a lot of these on-demand environments where we did most of our testing there. And then eventually we had a development integration environment, which was literally the first place where we put all the services there in a static kind of prod replica and said, this is the last place we're going to test. We expect everything to pass, but we're going to focus on certain kinds of tests before we go to a real staging environment, because the dev integration environment had like real databases instead of, kind of restricted test databases, right? So we looked at like what was different in those environments. The other thing that we see is that as we do patterns of on-demand environments, with this high rate of change, I need to be cautious, and I mentioned this earlier, of this kind of disrupting the static or shared environments as these new services are updated. So if I'm putting this new service C into this environment, what do I do with it, right? Well, one of the nice things about these ephemeral or on-demand environments is, what happens if somebody else puts a B in there at the same time? Well, what I can do is I can take my production kind of environment on the left and I can replicate that entire thing into my kind of test environment. And then I change one thing. All I change is service C, and I can test there. And I know if something breaks, I know exactly what broke and why. Now, one of the tricks of this is you got to figure out where you're going to get your data, right? How are you going to seed your data? Do you have snapshots of your database? Can you generate data? Things like that. So that becomes important, but it's very enabling to be able to create these different test environments. The other factors you might want to consider, right, is I've got all these services. I want to take lots of opportunities to test them so that I can enable these rapid changes through my business cycle. But it's past, like, which tests am I going to run where and why is it important? Well, some paths that are worth considering is that the first thing you want to do is think about testing in isolation, right? So if I have service A, I want to test service A by itself, and I might even want to mock out the interfaces and disconnect it from everything, right? Because this is where I verify what I think my contract is. So you built the service, verify that it at least behaves the way you think it does, right? And this could be API level testing. This is usually a deployed kind of running sort of thing. And a lot of this can, quite frankly, be handled with unit testing as well, right? Because that's the first step. You have control over it, test it by itself. Eventually, you want to test with your downstream dependencies, right? Which might be a database, might be other services, things that you need to invoke and get information from, right? Because now you're figuring out, which is what else do you need in order to function properly, right? And this, quite frankly, verifies what you think other people's contracts are. So if I'm A interfacing with B, I'm going to interface with B and I'm going to focus on that integration. I already tested my own functionality. Now I'm focusing on my integration with B and I'm trying to test it in a way that I understand that, yes, it still works the way I expected to. I'm getting the right kinds of information from B to do what I need to do. Because the third and potentially hardest kind of testing is what I will call testing your upstream dependencies, right? Now, this might be your user interface. This might be external services, right? So in this case, I'm A and I'm trying to test in the context of W, right? Because this is where you, quite frankly, verify what other people think your contract is. And this is where you figure out whether you're going to break somebody else by making the change that you just did. Now, a lot of times, unfortunately, when you develop in isolation, you don't necessarily know exactly how they've written their code or what they've done. So it's very difficult for you to do this, right? You may not even know who these people are, right? But at some point, something has to have this knowledge. And typically that thing is the pipeline, right? So your pipeline needs enough global knowledge to be able to orchestrate this kind of thing. Because what you want to think about is the pathological case of what happens when some API somewhere in the system changes, some service changes, maybe internally, and doesn't fulfill their potentially poorly specified or really misunderstood contract, which is, sure, I knew what their objects were and their calling interfaces were, but I didn't know what they actually did internally, right? So how do we figure that out? Well, that's the upstream stuff. And one of the patterns of success that I've done, and we've done at Coveros with some of our customers, is build and package what we will call executable tests and data scripts that match every service component. So in this case, if we look at it, our test candidate, the kind of top right there, is this thing we're going to call record management, right? And I'm building this API thing. And with every service that I build, so I build my API there, I also build this thing I'm going to call test exec, which is another running program that people can run at any time to execute my interface. And what I happen to know, or what the pipeline knows, is that this external thing, this case managed thing on the bottom, case management, has I know it interfaces with me and it invokes me at times because I've written APIs for these guys. I want to know if I'm still doing it correctly for them. So what I can do in my pipeline is, as long as they have built this test exec program, this container to go with it, what I can do is I can reach out, I can grab that test exec program and I can execute it against their service, and it will drive their service, which in turn will drive a series of integration tests that drives my service, right? And this is one of the patterns that we found very successful because it allows us to, at different points in the pipeline, execute some very focused upstream tests that generate traffic and flow downstream towards the services that are in change. So I can launch these local upstream tests during my automated testing, and it's very easy to do it. So one of the patterns that derives from that is that tests should live with the code and pipeline, right? So tests for microservices should be stored in the same repository with the rest of your source code for that service, right? This includes your unit test, which is kind of the duh, we always do that, right? Your unit tests live next to your code. Well, it also means your automated REST tests, if you're using Postman or something like that, get stored in your API repository, and your UI tests get stored in your UI repository, right? So if you're using Selenium to do it. Now, you may still have some external tests that live elsewhere, but every service is responsible for publishing a set of tests on how to test it, right? And those tests in general, are going to test everything, but you need suites of tests that are focused on things like integration tests. And by storing these things together, it allows you to easily match code versions to a test version, right? And by the way, pro tip, bundling all these things in things like Docker containers makes them super easy to execute. One of the challenges you're always going to come across, and I won't harp on this too much, will be what I will call cross-service or cross-branch testing. At some point, you're going to come up with a problem where service A and service C are both changing at the same time or have codependent changes. So what do you do about that? Well, there's a number of ways. There's different ways your teams are going to implement this, right? Sometimes they're code-based solutions where they'll use feature flags or different API versions or maintain 2 different versions internally. But ideally, what you would really like is for them to be able, one of them to be able to go first and be able to survive without the other one until the other one comes along and then have their codependent changes. Unfortunately, it's not always possible. And sometimes you have to maintain multiple versions. There are other deployment-based solutions where, quite frankly, I can run multiple versions at the same time. What you really want to know is, how do I test this, right? And again, it's going to depend on whether you've implemented it in deployment-based or whatever, but either way, you're going to have to figure out ways to test execution of this. And specifically, how do you launch this environment? Well, the way we ended up doing it many times was we wrote configuration capability where we could launch 2 different branches from 2 different repositories at the same time, build this environment, which would then allow the testers and the developers to test what they were doing. So, one of the options for doing it is to be able to deploy and execute these simultaneous branches, right? Where when you launch your environment, you can actually specify a dependent branch on another repository, launch these environments, build them together. It really just becomes kind of a core part of your pipeline that sometimes is self-service, right? Somebody might go and specify 2 branches and click a button and say, give me an environment. Again, you can build up a dynamic environment, boom, put the services in there that you want. Because ultimately, when you get to testing these simultaneous changes, you need those changes there running somewhere in an environment. Now, one of the anti-patterns that we've come across that I stress to avoid is when you have multiple versions of different APIs running kind of everywhere. It's like, oh, I've decided I want to deploy 2 versions of my API service, my A service next to each other. And I'm just going to do it temporarily. Well, what we found is when you start doing that for A, then you end up with B and C, and everybody's deployed all these different versions. And you end up with things like, how do you wire all these things together? How does W know which version it's supposed to talk to when it's invoking the other features, right? Sometimes you end up with data conflicts, which is A and A prime, the changed version, both have to share the same data store, because otherwise you have all kinds of other problems. Are they actually compatible, right? Does this mean you actually have to develop parallel versions at the same time for some long period of time? This tends to be just torture. Stay away from this unless you absolutely have to. Eventually, you'll get good at it and you'll be able to support, some parallel versions here and there, but it's definitely not what you want all the time. When it comes down to it, eventually you got to tie it all together. You're going to have all these pipelines. They're going to be executing in parallel. You're going to be deploying it into different environments. And this is really where you have all these opportunities, right? All these little boxes I've drawn are all testing opportunities, right? The bulk of your pipeline is going to be testing, not just kind of build and deployment. And that's how the pipeline aspect of things work. Now, there's a lot of also non-pipeline aspects that I can kind of go through quickly. The first one I harp on is I keep mentioning teams, right? Your teams have to align to your delivery process, right? They're likely part of a shared product. You're a company, you have multiple microservices working together, right? So they're part of a shared product. If they're truly independent, fine, rock on with your independence, do whatever you need to do. But if you are, don't pretend that you're separate more than you really are. You need to communicate with each other. So regardless of your level of separation, though, what you're going to find is that you likely have shared patterns, things like what you're doing in DevOps, your testing, your architecture, that could be leveraged without having to reinvent the wheel all the time, right? And that's part of what you want to do. One of the things that we've implemented at Coveros a number of times on projects is what I refer to as these horizontal technical guilds. And what it really is a group of specialized professionals that work together to solve cross-team problems, right? So you have things like a testing guild or a DevOps guild or a security guild. And these are what I refer to as cross-team functions more than cross-functional teams, right? Your kind of agile vertical team over here has people like developers and business analysts. And by the way, it's got testers and developers and security people. So the cross-team function is really how do you take some of those specialties and distribute them and manage them across the team, right? Because the guild members that become your test engineer, your DevOps engineer, that are assigned into a team, really focused on those team specific problems. So like, I need to deliver my software for my team. That's what I'm doing. I'm testing my software, I'm delivering it, I'm analyzing, I'm doing what I need to, right? But the centralized ones are the ones that add kind of cross-team structure, if you will. So they solve, how exactly are we doing our DevOps pipeline, right? So they're establishing those kind of cross-team standards for that shared success across the enterprise, and not just a bunch of isolated islands, right? And it becomes their kind of guiding principle to share that knowledge with those members. One of the challenges, by the way, security people are always in high demand. You're never going to have enough people to actually assign a security person to all of your teams. But it's good to at least have a representative that the teams know they can talk to. That's a whole other talk, right? So this is just an example of how we did it with, half a dozen teams or so, where we had DevOps engineers and agile testers assigned to every team. And then we had test leads, and I was the DevOps lead. And we added kind of like, we had some engineers to support tools and building guidelines and stuff like that. But then really what we did is this club of people that would get together and share standards while they were focused on doing the right thing for their teams. So it is, again, important for those vertical teams to actually work together, right? And this one of the things about the guilds and the shared aspect is it encouraged that. The last kind of thing I tend to harp on is being able to integrate this all with software architecture. Not necessarily all software lends itself to being easily built, tested, and deployed, right? So we need to work directly with the software architecture and development teams to make sure that it can be tested, to make sure that it can be deployed and configured, right? And that, we need some meaningful testable service architecture in order to be able to test it and actually verify that the surfaces work. So some of the important things about that, you need to be able to support a rapid build, right? We need automated tests so we can control and observe what's going on. We need to be able to initialize data. Once it gets installed, it needs to be configurable and not just hardwired to run in a single environment. We need things like monitoring and metrics and collecting logs out of all of these microservices in order to even understand what they're doing. Because eventually what becomes critical is how do I can debug an individual service, but how do I debug things across services? And these are just pitfalls that you need to look for. So what I would say is in guidelines for architecture, all of these things I just talked about on the previous page need to be standards and go into the definition of done to reflect these capabilities. The development stories can't be considered complete until those things have been handled and proven, quite frankly. And that's one of the jobs of your DevOps pipeline. Because people need to keep their eye on the game, right? We need to focus on product value and kind of keep cross-service features in mind. And the fact that this is an enterprise product. This is something that we are offering to our customers, not just a bunch of independent little children that are running around screaming, or, back to that whole herding cats idea. So what I would say is my takeaways from this are that your pipeline, if you don't remember anything else, your pipeline really is going to implement whatever your business and delivery model is. Pipelines without tests simply push bad code faster, which is why testing is so critical to what you're doing. Moving towards dynamic environments and, quite frankly, using things like Docker containers are going to make your life so much easier with microservices because of your ability to test different combinations of things. Along those lines, you want to store and branch everything together. If you have 10 repositories or 10 microservices, store the codes, the tests, the database, all the pipeline code with those repositories, because it'll make your life that much easier, right? You're certainly going to have to follow those test paths. You got to test in isolation, you got to test with downstream, and you got to test with upstream, because it's the only thing that's going to give you an impression of whether your system works correctly. Someday, maybe you'll have perfect microservices that have perfectly specified interfaces and work perfectly all the time. Until you get there, welcome to the real world. And these kind of tests become critically important. And then finally, as I mentioned, your architecture has to support rapid build, deployment, testing that can be thorough and integrated and happen all the time. And of course, don't forget, please work together. We're all on the same team. And with that in mind, thank you very much. Certainly, if you have any questions, you're welcome to reach out to me. These slides will be posted. You can get in touch with me. And by all means, if you run across problems like this, I work for a company that does this for a living. Feel free to reach out, and Coveros would love to talk to you about ways that we might be able to help. With that, thank you very much.